So welcome to our seventh video, part B. So last one, we talked a little bit about Dalton's atomic theory. This one, we're going to look at what do atoms look like? And yeah, there is a part C as well. But the focus of this one is what do atoms look like? So let's get to it. All right, 1700s, I suppose. This guy we talked about in the last video, John Dalton, came along and he said the world's made up of atoms. So obviously people said, hey man, there's these atoms out there. A lot of other people are going to go, well, what do they look like? How are they put together? What's going on with an atom? So that's what happened right after he came out with this theory. People tried to explore to understand what atoms were all about. How are they put together? What do they look like? Now, before we can actually get into a little bit about atoms, it turns out I got to tell you a little bit about electrical charges. And the reason for that is the first clues about how an atom is put together, the first clues came from understanding electrical charges. So we're going to spend a few minutes here talking about electrical charges. All right, now, electrical charges, you actually see this like on a battery, right? If you look at a battery, a little AA battery or whatever, doesn't matter, any kind of battery, D battery, there's always going to be a positive end to that battery, and there's a negative end to that battery. So the way electrical charges work is if you have opposite charges, like a positive and a negative, opposite charges will attract each other. So a positive and a negative, if you put them near each other, they're going to want to get closer to each other. They like each other. They're attracted to each other. And on the other hand, if we have same charges, so that could be two positives, or it could even be two negatives. If you have the same charges, they're going to repel. So same charges repel. They don't like each other. So two positives are going to try to get away from each other, or if you put two negatives, they're going to try to get away from each other. All right. There's one more fact I got to tell you about electrical charges, and before we can even get into atoms, and that is often you're going to have positive and negative things together in the same thing. So if you have, oops, little typo there. If you have positive and negative charges together, they maybe I should say it this way. Let me erase it, actually. We'll say their charges will cancel to form a neutral substance, to form a neutral substance. So if you have positive and negative charges together, their charges will cancel to form a neutral substance. All right, so with that, that's a little background on charges. So people started understanding electrical charges about the same time Dalton lived, like 1700s. And then eventually they could use this idea to help understand how atoms were put together. Now that leads us into kind of the first person to use this information and to discover that there was actually something inside of an atom. So let's flip over and talk about what he discovered. Okay, that guy who discovered that there was something inside of an atom, that there was a particle inside of an atom, that guy was J.J. Thomson. Now, this is a picture of him. You can see he lived and he made this discovery right around 1900. And actually, it was it was 1897 to be exact. He discovered a particle that was part of an atom. So if you discover something smaller than an atom, these particles are sometimes called sub means smaller, subatomic particles. So we discovered the first subatomic particle. Now, when you discover something, you get to name it. So this particle he discovered, he called it an electron. And he figured out one more thing about this electron. We'll say he also determined, let's say he there, he determined that it had a negative charge. He determined that it had a negative charge. All right, now there's one other fact people already knew, which is that atoms are neutral. Atoms are neutral. All right. So what does that tell us? So if there's a negative piece, and he just figured out the negative piece, and you know, all put together, the atom is neutral, what that also means is that there has to be what? There has to be a positive piece, because that's how you get to be negative, right? The way, neutral. The way that you get to be neutral is you have a positive piece and a negative piece together. So in 1900 or so, 1897, he discovered the negative part. So people then knew, hey, there's got to be a positive part. Therefore, if atoms are neutral, therefore, there must be a positive particle inside of an atom. All right. So basically what happened is people started to look for this positive particle. Now, the person who discovered the positive particle, that happened, maybe 10, 15 years later. And the person who did that was a guy by the name of Ernest Rutherford. So Ernest Rutherford in 1920, so it took like over 20 years to find this positive piece. It wasn't that easy. In 1920, he discovered the positive particle in an atom. And this positive particle, again, just like Thomson got to name the electron because he discovered it, the negative particle. Well, Rutherford discovered the positive part, so he got to name it. So he called it a proton. He called it a proton. All right, so he discovered the positive particle in an atom. He called it a proton. All right, so at this point, there was two parts that people knew of that made up an atom. There's a negative part, that's the electron, and there's a positive part. That positive part is called the proton. So the next thing people were curious about is, well, we know there's things inside of an atom. How are they actually put together? Like, what's going on? Are they arranged in some way, or how are they organized inside of the atom, these two pieces? So it turns out Rutherford also figured out kind of how these pieces fit together. So Rutherford, let's write a couple more notes about Rutherford. Rutherford also, miswrote there. Let me erase that. Also, we'll say, did an experiment that showed how these pieces fit together. How these pieces, I maybe I'll say it this way, combine to make an atom. How these pieces combine to make an atom. Now, the other thing I'll tell you is I'm going to tell you about how he discovered how these pieces fit together. And this is actually the only experiment we talk about all semester, so it's kind of like probably the most famous experiment in chemistry ever. And it told us kind of what an atom is all about, how it's put together. So this experiment, he used a piece of gold foil in it, and I'm going to show you a diagram of that in the next slide. So it's called the gold foil experiment. The gold foil experiment. All right. So Rutherford discovered the positive particle of an atom. The positive particle he called a proton. And not only did he do that, he also did an experiment that showed how these two pieces, the positive and the negative piece, get together to make an atom. That experiment is called the gold foil experiment. So let's go ahead and look at it. Okay, so this is what his experiment looked like. All right, 100 years ago, 1920, 100 years ago exactly. So back in the same time period, people were starting to get interested in like radioactive decay. There was people like Marie Curie and Pierre Curie and other scientists who were interested in this radioactivity, and they were starting to use radioactive substances. So radioactive substances, that's like uranium and plutonium and things like that. And whenever you hear the term radioactive, all that really means is it's a substance that is throwing out particles. Now, if those particles hit you, that can be dangerous when they hit people because they carry a lot of energy and they can like cause damage inside of your cells. They can give you cancer and stuff. So radioactivity just means it's a substance that's emitting particles, sometimes dangerous particles. Now, Rutherford got some radioactive materials, and what he did, they're shooting out particles, and he set them up in a little box here. This is the radioactive sample, and he had those particles shoot out. Now, they're really teeny tiny, right? They're tiny particles, and he shot them at a piece of gold foil, a piece of gold foil. Now, what would happen when the particles would hit the gold foil, he could kind of see where they ended up based on the fact that there was a screen around, and wherever the particles landed, the screen would like give off like a spark of light. It was a fluorescent screen. So what he noticed when he set this up is that typically, oh, let me flip one more thing, most of the particles would go right through the piece of gold foil. So most of the particles would just keep on traveling, like just plow right through the gold foil, all right? So what that kind of told them is the gold foil apparently didn't have a whole lot going on inside of it, right? Because things could just go right through it, could just travel right through it. But that didn't always happen. Once in a while, and when I say once in a while, I mean like 1 out of every 10,000 particles or so, something different would happen. And what would happen is the particles would ricochet off and land somewhere else. So instead of traveling straight through, they would bounce off and careen off and go somewhere different, and might even bounce straight back towards them. So what that meant, what that was telling them, is that most of the time, if you travel through an atom, you're going to hit a bunch of nothing. When you travel through an atom, you're going to hit a bunch of nothing. But every once in a while, you're going to hit something. And when you hit that something, it's going to cause you to bounce or ricochet in a different direction. So this experiment told them that there is something inside of an atom that you can hit. Now, the fact that he only hit it once in a while, and when I say once in a while, I mean 1 out of every 10,000 times, that told them whatever he was hitting was really small. If it was big, he'd be hitting it all the time, and most of the particles would ricochet off. But that didn't happen. It only happened once in a while. All right, so let's kind of sum up what he learned from this experiment. I think I'll just write it on here. All right, so what he learned is that atoms are mostly empty space. How did he know that? What told him that? Oh, the fact that you can just go right through and keep on moving. You don't hit anything. But he also learned, but there, we'll say, is a small hard part, a small hard something that you can hit and that makes you bounce back. There is a small hard part in an atom. And an atom. Now, this small hard part, he gave a name. Well, we'll put it right here. He called it the nucleus. He called it the nucleus. Oh, all right. So basically, this was telling them there's two regions in an atom. An area you can travel right through, and that's actually the bigger region because that's what mostly happened. And then there's a smaller region that has stuff in it that can cause particles to get deflected away, all right, and travel in a different direction. So with that, let's kind of sum up what an atom looked like. So basically, he discovered that an atom looks something like this. There is an outer region that is kind of empty-ish, not much going on, kind of, sometimes you'll hear it called kind of like a cloud. And then there is a hard center in the middle. The hard center, again, is the nucleus. Now, he also figured out that that's where these two particles were living. The outer area, the kind of not much going on, emptier area, is called the electron. It's where the electrons live. And so again, when particles travel, they can go right through that area. They just go right through. They just go right through. And in the middle, there is something a little firmer, a little harder. And it turns out that is where the protons live. So the protons live inside of the nucleus, that hard center of an atom. All right, so it turns out there's another particle in the nucleus that I haven't mentioned yet. It's called a neutron. So the nucleus contains two particles. The nucleus contains protons and neutrons. And then outside of the nucleus, you're going to find electrons. Okay, so let's sort of sum up what we know. All right. So there's three basic particles in an atom. There's three subatomic particles: protons, electrons, and neutrons. I haven't taught much about neutrons. I'm going to tell you more about them right now. Each one of these particles we need to be familiar with. So we need to know what charge they have, positive or negative, or could be neutral. Who discovered them? Where are they? Are they in the nucleus or outside of the nucleus? And then how big are they? And then the symbol. Each one is given a symbol. All right, so let's kind of go through that. Now, some of this stuff I've already mentioned, and let's see if it rings a bell. So starting off with a proton. What is the charge on the proton? What is the charge on the proton? It is +1. All right, it's positive. All right, so usually we say positive. To be a little more precise, usually we say 1 plus, so positive, +1. All right, what about an electron? What is the charge on the electron? What's the charge on the electron? The electron is negative. And again, to be a little more precise, usually we say -1, or usually we write it 1 minus. It's negative. All right, neutrons, again, haven't said a whole lot about neutrons. Neutrons have no charge. They are neutral, no charge. Okay, who discovered them? So we also want to know a little history. Man, these people are famous in science, at least, so we should know who the heck they are. So who discovered the proton? Who discovered the proton? That was Rutherford. Who discovered the electron? Who discovered the electron? That was Thomson. Now, the neutron was actually discovered, the last particle to be discovered, and most books don't even mention who discovered the neutron. What a shame for this guy. Your textbook doesn't even talk about him. But the guy who discovered the neutron was a guy by the name of James Chadwick. He gets shortchanged in all these textbooks. I don't know why. James Chadwick. All right, so Chadwick discovered the neutron. I haven't mentioned that one yet. All right, where are they? So things are either in the nucleus, that hard center, or they're outside. Now, two of them are in the nucleus. The ones that are in the nucleus are protons and neutrons are in the nucleus. In the nucleus. Finally, what's outside of the nucleus? Electrons is outside of the nucleus. Now, couple other, I'm miswriting the wrong word there. Oh, let me go ahead and fix that. outside the nucleus. Okay, now all these particles are small, so I do want to mention their size kind of relative to each other. Now they're all teeny tiny, teeny tiny, teeny tiny. You couldn't possibly see them with your naked eyes. But as far as how big are they compared to each other, protons are big, neutrons are relatively big. The electrons are relatively small. So they're kind of like little tiny things out there outside the nucleus just kind of going around. We're going to hear more about details about that in a future chapter. All right, so protons are big, neutrons are big. Electrons are way smaller. They're about a 20th of the size. Now, one last thing, typically instead of saying protons, electrons, and neutrons, instead of writing those words out, we like to use symbols. We like to use shorthand. Man, everything's got shorthand. So the symbol, protons, now this is one case where chemistry almost makes sense. Almost makes sense. Protons, the symbol for a proton is a P. Now, we actually like to kind of emphasize the fact that it has a positive charge. So you might see a P with a little plus sign in the top corner. Electrons, it almost makes sense. Electrons are going to be E. And again, we like to make sure you remember the charge on it. So with the little minus sign there. And then neutrons don't have a charge. So they're just N. Once in a while, someone might say, oh yeah, just let's make sure you remember they don't have a charge. You might see a little 0 there. Sometimes you won't see that. All right, so protons, P plus, electrons, E minus, and then neutrons with that no charge. All right, so those are the 3 parts of an atom. With that, we're going to look at how this relates to what's actually inside of an atom, because not all atoms have the same amount of particles. So that'll be in our next video. All right, so let me go ahead and stop this one, and we'll get to our next one in just a minute, part C, I suppose.